So, in the last lecture, we have seen what is sequencing and we have seen various rules for sequencing. So, in this lecture, we are going to discuss about one such algorithm, that is the Johnson's rule. Okay. So, Johnson's rule is applied when you have two machines and many jobs. We will discuss that with the help of an example. Here, we assume that all the jobs follow the same sequence. Okay. So if the jobs have different sequence, then we follow the Jackson's rule. And also if there are three machines and all the jobs follow the same sequence, we use an extended version of the Johnson's rule. So now let us discuss the Johnson's rule. So first let us look at an example. Then we will discuss the algorithm. So here we need to uh, schedule the jobs. So here it is given that we have five different types of jobs: J1, J2, J3, J4, J5. And in machine 1, the job 1 first passes through to the machine 1 and then to machine 2, like that, and also J2 goes through machine 1 and then to machine 2, and J3 go to machine 1, machine 2. So all these jobs have the same sequence. Okay, so we need to complete this job as early as possible. So how to schedule this? So should job 1 be scheduled first or job 2 should be scheduled first, etc. So this will be determined by an algorithm that is called Johnson's algorithm. Okay. Now, what we are actually doing here is that first we will consider the job which has got the minimum time, shortest processing time. So you can see that this J4, it takes a processing time of 1. Okay, let it be 1 minute in machine 1. Okay, so we will schedule it first. Okay, that is J4, right? Then next we will look at the next shortest processing time. You can see that this is 2, but this is to be done in machine 2, that is J5. So according to the algorithm, if it is done, if the job is to be done at machine 2, it will be scheduled last, that is J5. Okay, then we will look at the next shortest processing time. So that is 3, but this is already assigned. Okay, so we are leaving it. So the next shortest processing time is 4, so that is J2. So since it is done at machine 2, it will be assigned last, so that is J2. Okay, so now let us look at the next shortest processing time, this 5. This is already assigned here, this is 5, this is already assigned. Okay, next one is 1. Okay, see, this is 1, so the processing time is 7. So that means since it is carried out in machine 2, we will assign it as J1 here. So next one is J3. We need not look at. So this will be the sequence of operator. This will be the schedule. First J4 will be carried out, then J3, J1, J2, J5, etc. So this will be the sequence of the jobs. Okay. So we will look at see it once more. That is, the smallest time is 1 for machine 1, for it is process it first. So J4. Okay. So I will just clear it. So first J4, and then smallest time is 2 for machine 2, so it will be processed last. The next possible time is 3 for job 5, but job 5 is already processed by machine 2, so we will discard it. Next possible time is 4 for machine 2, process it last just before 5, just like we have seen J2. And next possible time is 5 for job 2, but job 2 is already processed like we have seen in the example, so we will discard it. The next possible value is 7 for machine 2, process it last just before J2. So similarly, we have assigned all the jobs. So this is the Johnson's algorithm. Now let us look at the steps of Johnson's rule. So it minimizes the makespan time while scheduling a group of jobs on two workstation. Okay, so scan. The step one is to scan the processing time at each workstation and find the shortest processing time among the jobs not yet scheduled. If the two or more jobs are tied, choose one job arbitrarily. Okay. And step 2, if the shortest processing time is on workstation 1, schedule the corresponding job as early as possible. And if the shortest processing time is on workstation 2, schedule the corresponding job as late as possible. And step 3, eliminate the last job scheduled from further consideration. Repeat steps 1 and 2 until all jobs have been scheduled. Okay, then we need to find the make span. Next step, we need to find the make span time. Let us see how we are doing that. So here we have found the job sequence as this one: J4, J3, J4, J3, J1, J2, J5. So we have found the sequence. Now to find the make span time, so we have the machine 1 and machine 2. Okay, you can see in, out, here we have in, out. So according to the sequence, we are doing job 1. We are processing job 1, job 4 first, then job 3, then job 1, job 2, job 5. So that means, so the in time of J4 is 0. We are starting the job. Then its out time will be 0 plus 9, that will be 9. Sorry, it is be in, out. So J4, it will be starting will be 1 and processing time is 0 plus 1. Okay, and of this job 4 is completed after 1 unit of time. Let it be 1 minute. After 1 minute enters machine 2. So here it takes its entry time is 1, out is 1 plus 5, that is equal to 6. J3, so you can see here for job J3, see the entry time. So machine 1 is free after 1 minute. So J3, it is processing time is 10. So 1 plus 10, that is 11. Okay, and for machine 2, the in time is, see, you can see the machine 2 is free after 6 minutes or 6 units of time, but this job 3 is available for machine 2 only after 11 minutes. So its starting time is 11 minutes and processing time is 11 plus 9, that is 20. Okay, you can see that here there is a delay of 1 minute, and here actually the delay will be 5 minutes. Okay, there is a 5-minute delay. And for J1, so then you have the job 1, so its processing time is 9. So the entry time will be 11. After machine 1, it is 11. So 11 plus 9, that is 20. Okay, it is 20. And in machine 2, so will be free after 20 minutes, and this job J1 is completed after 20 units of time or 20 minutes. So the starting time in machine 2 will be 20. So it will be 20 plus 7. Okay, the processing time is 7, so that is 27. And J2, it will start at 20. Here this machine will be, machine 1 is free after 20 minutes, so it is 20, and 20 plus 5, that is equal to 25. And here machine 2 is free only after 27 minutes. Okay, so we will take the greater of these two values here. So it is 27. So 27 plus 4 is 31. Okay, it is 31 minutes in J5. So J5, the job will start at 25 minutes. So it is 25 plus 3, that is 28. So this machine 2 will be free only after 31 minutes. So 31 plus, for J5 it is 2. 31 plus 2, that is 33. So job will be completed after 33 minutes.